Hello learners and welcome to your natural sciences lesson. So today we're going to be looking at the safety with electricity, how to be safe when working with electricity. But before we start, did you know that when working with electricity, you need to switch off, isolate and properly earth the circuit before doing any work on the circuit? So in this lesson, we're going to be looking at the safety measures that you need to take when you are working with electricity, some safety practices that you need to undergo when you want to work with electricity. But before we begin again, we are going to now set two goals that we need to achieve by the end of this lesson. So by the end of the lesson, you should be able to explain that parallel circuits can cause overload on main circuits. And number two, explain that circuit breakers, fuses, and earth leakage systems are safety devices. Now, these are the goals that I want us to achieve by the end of this lesson. But for us to be able to do that, we are going to take the main idea being the safety with electricity, the safety practices that we need to take when working with electricity. We are going to start at looking at the safety practices when we are working with electricity, and then lastly, look at the earth leakage circuit breakers. So these are the two concepts that are going to help us better explain the main idea when looking at the safety with electricity. Now, things that you already know about either electricity, the connections of the electricity are as follows. That number one, an electric current is the movement of charge in a closed conducting circuit. We also know that an ammeter is a measuring device used to measure the electric current in the circuit. Remember that this device, an ammeter, must always be connected in series in any circuit diagram because of its low resistance. So it has a low resistance, so therefore it always needs to be measured, it always needs to be connected in series. Also, what we know is as more resistors are added in parallel, the total resistance of the circuit decreases. So the more resistors we add in parallel, we are actually decreasing the total resistance of the circuit. And remember, by decreasing the resistance of the circuit, we are increasing the current strength of the circuit, because the relationship between the current strength and the resistance is inversely proportional, that when one goes up, the other one goes down. They are never going to increase at the same ratio. So with what we know, can we then be able to answer these questions that are based on the information that we already know? The first question says, what can you say about the current in a parallel circuit? So remember, clue here is current that's in a parallel circuit. What we know about current in parallel is that it divides proportionally depending on the resistance of the circuit. We know that current will always look for the path with the least resistance. So that means when you have a parallel circuit, we're just going to use one cell. Resistor. And this resistance, let's say it's 3 ohms, and this resistance is 6 ohms. So the current will always choose the path with the least resistance. That means when your current is moving from negative to positive, as it gets to this point, it is going to divide proportionally. The bulk of the current that we have on this circuit is going to be passing through the 3 ohm resistor, because this provides the least resistance. However, the least current, or the small portion of the current, will pass through the resistor that has the resistance of 6 ohms. So therefore, current will always look for the path with the least resistance. Now, the options given to us are, what is it that we know about current in parallel? None of these we know. Or B, it is going to be the same everywhere. Or C, it is the same in each component. Or D, the total current supplied is equal to the current in each branch added together. So now, the total current supplied by the battery, it is going to divide when it gets to this point. Remember, after passing through this point, it is still going to add up together and still be equal to the total current that we had initially. So the total current supplied is equal to the current in each branch added together. Our answer is D. because after having passed through the resistors, the current that we find on branch number 1 and branch number 2 added together will be giving us the total current of the entire circuit. Question 2. What happens when one light goes out or removed in a parallel circuit? So in a parallel circuit, as we can see on this one here, what is then going to happen if this resistor is removed, or if this resistor it is blown or it goes out? What's going to happen to this other light bulb that we have in parallel? A, nothing happens. B, all lights go out. C, only that light goes out. Or D, half of the lights go out. So if we have 5, 6, or 7 resistors or light bulbs in a house, if one of them goes out or one of them is removed, what's going to happen to the other lights that we have in the very same house? So all the other lights will still be able to function, they'll still be able to work. Only that one that was removed or only that one that went out will not be functioning. So therefore, our answer is C. Moving right along. Throughout this lesson, there are certain ways that you're going to be using to better explain the main idea when we're looking at the safety with electricity. We are going to be using words such as circuit breaker, earthing, electric current, and also electric circuit. Now, before we jump to our first concept of the lesson, we're just going to quickly go for a short break, and I will see you just after this.